Right, so we're going to have a look at how we can validate our entities. Okay, so digital certificates are really focused on validating the entities that we have. So there might be network connections, it could be data, or it could be services. So we'll show you how it really works, how we can create secure connections and how we can prove identity. Okay, so there's Bob's public and private key. And we've got Alice's public and private key here. And then we've got Alice's digital certificate with her public and private key on it. And there is Bob's. So there's several ways that we can prove identity. The first way is what's called one-way authentication. In this case, only one of the parties authenticate themselves to the other side. So let's say it was Bob to Alice. So Bob would actually send his digital certificate to Alice, and she would check it. The other form that we have is what's called two-way authentication, and in that way both Bob and Alice will actually send their certificates. Okay, so let's now look at an example. And we see digital certificates fairly often inside our web connections. Okay, so here we have Bob. So Bob's going to connect to a website, and we'll call that website Alice. Okay, so how do we make sure that the connection is kept secure, and also that we can prove Alice's identity? Well, we have Trent in between, and Trent signs the digital certificate from the server, which is Alice in this case. So we see our certificate at the top with a little padlock, and that means that the certificate has been sent and it's been validated. It's been signed by Trent, a trusted certificate authority. We can check the certificate if we want on the browser bar, and it should give us the details of who issued it and who it's issued to and when it's valid and its fingerprint. So with web traffic, we now get the concept of what's called HTTPS. That's basically HTTP with some SSL. And the certificate itself validates the entity, which is the server. So one thing that we need is that we need actually to create a key for the secure communication between Bob and Alice, between Bob and the website. And this is done through what's called key exchange. One key exchange method is Diffie-Hellman. Diffie-Hellman allows Bob and Alice to openly communicate, and then at the end of it they will come up with a shared session key which will be used for the tunnel to be able to access the website securely. Even though Eve is listening to the communication, she can't work out what the key is that Bob and Alice will actually share. So Diffie-Hellman method is used fairly extensively in the industry, and for this we create a session key. So the session key is normally AES encryption. We typically use private key encryption for our main encryption tunnel that we have. This allows Bob and Alice to be able to communicate, and also for Bob to prove the identity of Alice. Okay, so there's our session key. Every time we connect to a website, we get a new encryption key. Every time we connect to Google, we should see the little green bar because Google uses HTTPS by default. So Google is sending their certificate to us for us to check. So how does the mechanism actually work? Well, let's look at an example here. So here we have Bob, and there's Alice. So Alice in this case is Google. So Bob is connecting to the website. So initially Alice will send her public key. In this case it's Google. Google sends the public key to Bob. And on that public key, the public key is held on the digital certificate that Google sends through. One method of generating the key that's going to be used for the encryption tunnel is to take Bob's session key that he's just created. Typically it's a 180-bit AES or 256 AES, and then he will encrypt it with Alice's public key. So then he sends that back to Alice, and Alice, who is Google in this case, will be able to decrypt with her private key. In this case now, they both have the same key, and it is this key which will be used to create the tunnel between Bob and Alice. So we have not only validated the identity of Alice, we now have generated a shared key which will be used for the tunnel to keep security. So obviously one risk that we would have is that someone steals Alice's private key. They can obviously get Alice's public key, so then an intruder could pretend to be Alice. So now we have a tunnel created, and the tunnel will use the encryption key that we've actually just generated. So overall, we're using public key, RSA, to prove the identity of Alice to Bob. It's only one way identity checking. We create an encryption tunnel, typically with private key, and mostly with AES, 128-bit or 256-bit encryption. And then we have some key exchange method, such as Diffie-Hellman or the RSA method that we actually saw just there. Okay, so in this way we can actually prove we can validate entities and create secure systems.